Alright, this is part 2 of the video tutorial for ALTEVAL program. In part 1 we discussed the basics and underlying concepts of alternative evaluation in general. I intend to really get to nuts and bolts of the program and show how the program can be applied and used. I will not go over the program installation in this tutorial. That is in the user guides. It's pretty straightforward, and please review in order to see how to install the program. ALTEVAL program has 5 different methodologies to conduct alternative evaluation. I'd be using some hypothetical examples in order to do a demo of how to run and get the output for alternative evaluation program ALTEVAL. And with that, let's get started. Okay, so these are the 5 methodologies I just talked about. Simple method, additive weighting, technique for order of preference based similarity to ideal solution, which is also known as TOPSes, Minkowski distance, and K nearest neighborhood machine learning. These are the 5 different algorithms which is applied in ALTEVAL, and I'll go one by one. Okay, first I described the simple method. Really, for simple method you don't need ALTEVAL. You can simply use any spreadsheet to get the result, but just to have a comprehensive list of methodologies, I've included it in ALTEVAL. The very first thing that you need to do for all these methodology, create an input file. And the good thing is input file can be created in an Excel spreadsheet. This is an input file created for an example about hiring an employee, let's say, or several candidates, employees, and evaluate those candidates. And generally the category or criteria goes on top. These are the criteria that goes on the top row. Years of experience, education, registration, certificate, university grade, publication, recommend, or whatever, however you design it. The first column is name of the alternatives. The second row is MOE, measurement of effectiveness. It happens that here in simple method usually the category or criteria and MOE are the same. But remember, there are cases like, I brought an example where we say criteria is traffic. We want to improve traffic. That's a criteria. But then how do you measure criteria? And therefore you come up with several MOEs that relates to traffic, travel time, travel distance, and so forth. You say criteria is environment, but then how do you measure? Then you come up with several MOEs like CO, NOx, and HC. But here in simple method, usually category and MOEs are the same, pretty straightforward. And then objective. It happens that on all of them, increase is the objective. You want the value associated with these MOEs to go up and increase. Let's say for some case you have cost as MOE. You want cost to be reduced. So here we don't have that. So for all of them we just have to type increase. If there was a MOE that we need to reduce it, then we would have typed reduce. It has to be either increase or reduce. So these are the 3 rows that has to be done like this. You could have different MOEs, different criteria, however you design it, doesn't matter. It happened that in this particular example the user has different ranges for scoring each of the MOEs or categories. But sometimes some users that they say for all of them, each of them use 1 to 10, and then we could use weight for each of them, which weight is actually an option in the program that can be used. But anyway, this is an input that need to be created just like this. with the first column being the alternatives, a name of candidates or whatever you have in any example, and then categories, MOE, and objective. You enter either increase or reduce for the objective depending on the direction of your MOE and whatever objective direction is. And then you put the values here, and now you have the input file ready, and you could run the program by calling this input file. Alright, now it's the time to launch the ALTEVAL program. When you launch the ALTEVAL program, this is basically the screen you see. The very first thing that you need to do is to let ALTEVAL know where and what's the name of your input file. Remember that spreadsheet we just created? So we type, it is in C demo, and then it's called employee.xls. This is the same spreadsheet that I just showed you. This is the input file. Then the remainder of the ALTEVAL screen pops up. It has got all these criteria or MOEs on top of it. You could go to each of them and then change the weight if you want. In that particular example, the weight was already embedded, because remember they had different range, the scoring system had, but let's say if they had same range, all of the scores from 1 to 10 or 1 to 5 or whatever, then you could change the weight here for each criteria. Already by default the simple method is toggled on, and then you simply just click and bingo. So what it says is Arthur gets the score of 53, and he's the first winner, the first best, then second best, third best, and so on. So it gives you all the list of all the candidates, whichever comes top and all the way to the bottom. And the same file is also created in the same folder that input file is, with a unique name in a spreadsheet. So you could have the same result in a spreadsheet. As simple as that. In terms of mathematics, what it did, basically the program, it added up all those values and came up with this result. In case there was an objective direction as reduce, it would subtract. But remember the spreadsheet I went through, it all had increase as objective direction. In case some of them are increase and few are reduce, let's say, remember I said about cost, which you need to reduce, then instead of summing it up, adding it up, the ones which are reduced will be subtracted and the ones otherwise will be added. The sum will be shown here as it's presented in ALTEVAL output. Okay, so with that we know how to do simple method. As I said, it's not that big deal, and that can be done easily in a spreadsheet, but the more exciting methodologies come up next, so stay tuned. Yeah, but first let's clean up this screen and get ready to apply the next methodology. So we go to kernel, restart and clear output, and again click on restart and clear all outputs. Then again back to the first item in the ALTEVAL, and we are now ready to run the next methodology, which is called additive weighting. Okay, first and foremost, the very first thing that the user need to do is to create an input file. For all this methodology, that is the very first requirement. The input file can be done in a spreadsheet, Excel spreadsheet, as you're looking at right now. This is an example of transportation planning again. And the tab on the sheet should be called input. So that's one of the requirements when you create this input file. Just like the simple method, the very first column also should be the alternatives. The first row is category, the second row is MOE, measurement of effectiveness, and the objective direction, whether these MOEs and the desire is to reduce each or some of them to increase. For instance, this is public transit ridership. We want the ridership to be increased because we want to encourage using public transit in this particular example. What we see here, which is different than the example I gave you before, these categories or these criteria are divided into different MOEs. So for instance, the first category, roadway, it has got 1, 2, 3, 4, 5 different MOEs, that these MOEs represent how the roadway will function. Public transit has only one MOE, so the criteria and MOE is the same for public transit. How does the non-motorized function? This is what we want to evaluate. That also has 5 MOEs that describe non-motorized system. Then we have environment category, which CO, HC and NOx will represented, and energy, which is about petrol consumption. But then again, I mean, it's flexible, depends to the problem you're trying to solve, or even transportation planning can have more categories, can have less categories, and can have more MOEs. That depends on the user and how you design your system, what data you have accessible and available, and so forth. So you just type your categories, your MOEs, measurement of effectiveness, and the objective direction, reduce or increase. Then you put the values for each alternative. These are hypothetical values. I just put some random number because we are just not doing a real exercise. This is just an example. But that's where you see the robustness of additive weighing methodology comparing to the previous simple method. With additive methodology, you don't have limitation on what type of data you can put as value. In simple methodology, you were imposed to put rates, and rates are subjective. You're judging, for instance, instead of years of experience, I had an example, you just put rate 1 to 10. But if you put the exact years of experience, that would be more robust way of evaluating the system. So you don't have that judgment element when you rate things. And if you don't do rate, then you have to put all the variables with the same unit of measurement, because in that methodology you add up all these columns together. So in order to avoid having apple-orange comparison, all of them had to be rates, or all of them had to be years, or all of them have to be kilometers. So they have to have same unit of measurement. So you could add them up and see which one gets the highest, which one gets the lowest. That has some limitation which sort of make the evaluation not as accurate and not as reliable. But in this methodology, you are flexible. You could put rate if you want. You could put interval scale, meaning the actual number, and so forth. So that's the main advantage of this system, that the mathematics that will go into solving the evaluation problem, it doesn't have any limitation, and it could really deal with the actual data to the point, to the decimal even. Those values could go in, and if there are some variables that you cannot have the actual number, you could put rate and it will work just fine. So this is basically how you set up your input file in Excel, and now we are ready to run the additive weighting methodology and evaluate and see which of these alternative makes it as the first, second, third winner and to the last. So let's go from there. Okay, we just created a spreadsheet, and that was an example of some transportation planning, and we need to now run and develop alternative analysis and evaluation using additive weighing. So we launched the program, and as we launch, this screen will show up, and now we need to introduce the name of the input file we just created. So it's in C demo, and I've called it traffic.xlsx and enter. By the way, if you type the name wrong, you simply go to kernel up there and then restart and clear output. Okay, now once we call that input spreadsheet file, ALTEVAL reads it and puts all the categories or criteria in different tabs. See, public transit, non-motorized, environment, energy. And the very first thing that ALTEVAL does using that spreadsheet, it goes and counts number of MOEs per category. For instance, roadway has got 5 MOEs. Environment has 3 MOEs. Public transit, as you remember, had only 1 MOE. And then it calculates the maximum number of MOEs. So the maximum number is really 5. A roadway has got 5. A non-motorized has got also 5. So once it calculates number of MOEs, maximum number of, it gives 5 as the weight for each category. So by default, because ALTEVAL wants to use, the default is to use similar weight for each category. So each category gets 5 based on the maximum. In that case, environment, for instance, has got 3 MOEs. So 5 being divided by 3, each MOE gets 1.67 weight. So adding them up, environment gets 5. Public transit, it had only 1 MOE. So 5 goes all allocated to that 1 MOE. Roadway had 5, and therefore each MOE gets 1. And now this is a default. So by default, each of these categories get 5 as their weight. Now, and then a user has option to change these MOEs, and it could just scroll these and increase it and so forth. Now, generally, it's a good idea that users initially apply this default value of weight, but then changes the weight to see how sensitive the result becomes as weight changes. And easily can be done, and lots of what if analysis can be done if these weights are changed and so forth. So we want to do additive weighting, and therefore we click on this additive weighing here, and that's it. Click and see what the result is. So similar again, of course the result is shown here with alternative 17 is being the first winner. It's descendingly in order. Alternative 29 is the second, and so forth. Same result is also generated, just like the simple method, in the same directory, same folder as input file in a spreadsheet. So you could go to that spreadsheet and do graphs or whatever else the user needs to do it. So with that, additive weighting gets the result. And now we need to explain what happened and what sort of mathematics was used here. That process ended with this result. So this page explains the mathematics that is applied in order to normalize those numbers, those values, And as you know, they had different scales. Some of them maybe could be rates, as I explained. Some of them could be continuous actual value, as we call it, interval. And they could have different units of measurement, some of them in thousands, some of them in tens. So what happens, as it's shown here, if the objective is to increase the MOE value, remember we had objective direction, it goes and divide the input value by the square root of sum of the input value to the power of 2. You can try it yourself. Just take few numbers that are in thousands and another column, let's say 3, 4, 5 numbers, and another column which you have numbers in 10, let's say, totally two different units of measurement and different scale, and then do this operation. You'll see how the numbers become within the same range basically, and the numbers, the values become dimensionless, consistent. So when that happens, you can add them up. Then it's not apple-orange comparison. They could be added up. And if the objective is reduce the MOE value, it's same formula as above, but you subtract it from 1. So that way also, whether the objective direction is increase or reduce as a result of these two operations, then all of them will become better, most preferred, when the value is the highest. Then increase and reduce becomes meaningless. All of the values at these points are normalized, and the higher the better, regardless, all of them. One last operation will be done. The normalized value will be multiplied by the weights. Remember the weights that we defined? So those weights are getting affected here, and finally this the result, they sum it, they add them up, and the final score is the result of summing all the values and adding them up. Again, just one more comment about the weights. I would strongly suggest that first you run by the default when all the weights for categories or criteria are the same, and then do some what-if analysis, change the weights. Sometimes clients, you may ask them what sort of weights depending on their value, then based on the weight that they consider, apply another scenario and see how the result change, and then do another set of weight based on the consultant's impression of what the weights should be. Sometimes there are some citizen participation that can happen, and then the citizens could have input as what do they value. Do they value more for public transit or auto or so forth? How much do they value for environment versus others? So these are the types of what-if analysis that could be done. Basically, this explains the mathematics that has been applied for additive weighting.